Well, hello, AP Statistics students. Mr. Eicher here. Going to look at mock exam number 4, question number 2. This is a 15-minute question. This question might have taken you longer than 15 minutes. Here is me trying to guess that the questions on this year's exam might be lengthy with a lot of writing and explaining. And College Board has been clear that you don't have to finish all the parts to even get a 5. So if you weren't able to finish all the parts, that's okay. You could still pass. You could still get a 5. This question tried to write a lot of probability stuff in there that you might see. And the Independence Fish Hatchery is the place that my wife and I got married a couple years ago. She grew up in Independence, California, and in Independence, California, which is about 5 hours north from San Diego County. There's a fish hatchery with a really nice outdoor setting. So we got married outdoors there. So she'll probably put a link so you can check out the Independence Fish Hatchery. I think it's still operational. It doesn't really have an interpretive center, but I needed that to be able to ask a question later. So I made that up. Liar! So we're told recently stocked its lake with 3,000 fish of various sizes. They're a hatchery, so they hatch fish. But the distribution of lengths is approximately normal, we're told. Part A, basically a Unit 1, Chapter 1 type of question, describe the distribution of this dot plot. Now on the AP exam, you might be given a box plot or a histogram. I think we've done other videos and done other practice with those, but I wanted just a straight up dot plot. So to get full credit, make sure that you mention the fish length. That's probably the most important thing, like I've said in other videos. The length of fish. The center is around, so I've addressed the center. It's around 8.2-ish. Now you can find the median. I wouldn't recommend typing all the data into your calculator and trying to estimate. That's just a waste of time. The spread, I estimated what the range is, the high minus low. So the range is about 5 inches. I addressed the shape. It's roughly symmetric. Didn't really particularly look left skewed or right skewed. That's kind of flat, uniform, with no apparent outliers. I say apparent because I'm not necessarily sure that one is an outlier. But if you made a box plot out of this, it would not show up as an outlier. I included the data here if you're really interested, if you're really interested, but you probably wouldn't be provided the data on the AP exam. And I make a couple notes. Should be careful. Be careful about saying that it's roughly normal. We're used to talking about a roughly normal shape. We are told the population is roughly normal, but with only 10 data points, I don't really see a mound shape, right? I don't really see a shape like that in this dot plot. It's just kind of, flat. So don't say roughly normal here. And again, be careful that you mentioned fish lengths for context. Okay, so that shouldn't take too long. So other questions. Now this question B was based on an AP exam question from 2007 that I really liked. I liked because number one, it's probability. And number two, you can answer it without a calculator, or you could answer it with a calculator. You will be able to use a calculator on the AP exam, though it might not be that helpful. But the question says the mean for all these fish in their lake is 8 inches. Which would be more likely? So this is a probability question. Which is more likely? A random sample of 16 fish having a mean greater than 10, or a random sample of 64 fish with a mean greater than 10. So the basic idea is we're expecting the sampling distribution, whether our sample size is 16 or our sample size is 64, we're expecting the sampling distribution of X bar to be roughly normal. The population is roughly normal. And it will be centered at 8, we're told right here, 8. So if we took a sample of 64, if we took a sample of 16, our standard deviation, if we actually knew the population standard deviation, the variability would be this, sigma over square root 16. Versus this one, the variability of the sampling distribution of X bar would be sigma over 64. So the top one, this one, is going to have more variability. So maybe I'll make my normal curve like this. Tried to center it, I kind of missed, but tried to center it at 8. And then for this one, the variability is going to be more compact. It's going to be, what's that, about half as much variability. So I'll just kind of guess that it looks like that. So when we're asked which is greater than 10, 10 on the scale, say like right here is 10, greater than 10. So which is more likely, which one has more area under the curve? The black n equals 16 or this blue n equals 64? So to be able to describe this, you'd want to mention that both of these curves will be roughly normal and both will be centered at 8. However, the key is that the n equals 16 has more variability and the n equals 64 has less variability. So the n equals 64, this n equals 64, will be closely clustered around 8, whereas the n equals 16 has more variability away from 8, away from 8. So that would imply that this area under the blue curve is going to be very, very small, very unlikely for the blue curve, but you could see the shaded red there, that is going to be more likely for the n equals 16. So as a quick answer, I said the answer is the 16 fish one. The smaller the sample size, the greater the variability in sample means, making it more likely to get extreme values far away from the mean of 8. If we use 64, so if you're given, if you have to choose between two options, choose the option. Really important test taking tip that I mentioned before, but explain the one that you pick and then why not the other. So as I've explained here, for 64, there's greater for 16, there's greater variability. So it's going to be more likely to get observations or sample means that are greater than 10. Whereas, why am I not picking the other? For 64 fish, the variability decreases, more closely clustered around 8, so it's less likely to get observations far away from 8, like greater than 10. If you want more details on the scoring or on how College Board answered this, probably with a calculator, you could see the 2007 number 3 part A question. I believe that the numbers are the same. I did try to make these numbers reasonable to take square roots. So as you can see that I've written over here, one is sigma over 4 and the other is sigma over 8. So this one has more variability compared to this one. You could also, well, I guess you can't actually use normal CDF because you don't know sigma. You don't know the population standard deviation of lengths. So I really like this question because it is really getting at the idea of sampling distributions and sampling variability compared to just, rotely, mindlessly typing stuff into normal CDF. And I think the exam this year will be kind of like that, more like using statistics, analyzing things rather than just using a formula or typing things in your calculator. So that was part B. Part C, suppose the standard deviation of the sampling distribution of the sample mean for random samples of size 64 is 0.25. So what that's giving you is sigma x bar. The standard deviation of the sampling distribution would be this formula, and we're being told that that equals 0.25. If the mean length is 8, like before, use the normal distribution to compute the probability that a random sample of 64 will have a mean length less than 7.5. So first, I had to fit somewhere finding a z-score in here. So z-score, we have our boundary is 7.5. Our mean is 8. And our standard deviation of our sampling distribution is 0.25. So that would be negative 0.5 divided by 0.25. These numbers are pretty reasonable to do without a calculator. That's why I chose them. So we get a z-score of 2. And also from AP Stats, we don't use a lot because we have normal CDF, but there is this 68, 95, 99.7 empirical rule. So even without a calculator, the percentage of observations that would be less than 2 standard deviations away. 1, 2, 1, 2. So here's negative 2. You want to find this area. And even without a calculator, you should know that the percentage of observations between 2 standard deviations is 95%. And if that's 95, then this would be 2.5%, and this would be 2.5%. Now you could do normal CDF. Whether you use a z-score or not. You do normal CDF, it's negative infinity to 7.5, 8, and then 0.25. Now, if you did that, left it like that, that would be the wrong answer. Even if you wrote, I think it's approximately that. Remember, you have to label lower bound, upper bound, mean, and standard deviation if you do have to use normal CDF. Normal CDF is kind of fair game. They've given us tables. I don't think it's likely that they'll ask you normal CDF. If they do, maybe they'll ask you like an empirical rule question where you don't even need normal CDF. You can estimate that the answer is 2.5% based on the empirical rule. So what is the probability that we get a sample mean less than 7.5 inches? That would be about 2.5%. A little more accurate, it's about 2.3%. Question D, suppose the distribution of fish lengths in the lake was non-normal. Remember at the very beginning, we were told right here that the distribution is approximately normal. But let's suppose that the distribution was non-normal. Had the same mean, same standard deviation as before. Would it be appropriate to use a normal distribution to compute the probability in part C? Justify your answer. This question I really like too, because there's probably something on your cheat sheet, your formula sheet, your summary sheet, I should say, that addresses this, but it might be hard to find if you don't know what you're looking for. So you still need to know some stats to answer this. You can't just rely on your notes completely. But the idea is the probability that we calculated in part C was using n is 64, our sample size was 64. So we would say yes to the question, 64 is large enough based on the central limit theorem. So the sampling distribution of x bar will be roughly normal, even though the population is non-normal. You might remember from class, hanging on my wall, wouldn't it be nice to be in class again? Hanging on my wall, there's a distribution of baseball salaries that we investigated. And the population distribution of baseball salaries is very, very right skewed. However, when we started taking samples of size 2, of size 10, of size 30, gradually the sampling distribution of x bar, the distribution of the sample means, gradually became more and more normal. So if we took a sample size of 1, then our distribution is going to kind of model the population distribution. As we increase our sample size, the distribution is going to start to look roughly normal. So that's the central limit theorem. As you increase your sample size, the distribution of the sample mean will be more and more normal. Approximately normal. And then the last question, I wanted a question about something from sampling experiments. So I had to make up this interpretive center. but a docent, someone who is kind of a museum worker, asks visitors questions to test their knowledge on the fish sheltered there. The docent gives each visitor a list of questions, including this one. In the past, our fish have averaged 8 inches in length. How long, on average, do you think our fish are now in light of the radical changes that have occurred in the environment? Explain how bias might have been introduced in the question. And, so very important that you answer both questions. Maybe on your paper, what I would recommend, if you see that like, hey, they're asking you two different things, I would do like a number one and number two, just so you don't forget to answer that number two. That's maybe like one of the most common mistakes, other than forgetting context. The most common mistake is just not answering the question. There was an AP Classroom video where students were asked to calculate and interpret a residual. And a lot of students calculated it correctly, but never even interpreted it, which just means if they forgot. So it might help you if you do a little like 1 and 2 to remind you that there are two things to say. So the way that I've answered this is this question wording leads people to answer lengths smaller than 8 inches, since the added information and wording about radical changes to the environment may lead them to believe the fish are unhealthy compared to previous years. This will lead them to, okay, here's my number 2. This will lead them to underestimate the point estimate of the mean fish length that all visitors who answer the question may guess. Now, you don't have to say that it's going to underestimate. Maybe you want to try to argue that, like, hey, because of the radical change, this might be a different approach. Because the radical changes, maybe the fish are getting longer because they're like becoming mutated or something. So now they're going to be ginormous fish or something. You could argue either way, as long as you come up with mentioning, hey, this radical changes is going to lead people to believe one way or the other. And I chose the unhealthy direction. And also, just to point out one more time, to make sure that you mention that underestimate or overestimate, whichever one that you guess. Well, thanks for watching this video. Give me a thumbs up if you like this video. Thanks for all your hard work on all these mock exams. This was mock exam 4. You'll have a mock exam 5 also this week. And then next week, we're getting really, really close to the exam. So exciting times. Hope you have a great day today.